This is for section 2.2, quadratic functions, and obviously quadratic functions play a big role in algebra and pre-calculus, and a lot of things we can do with them. Now, as far as calculus goes, you need to be familiar with quadratics, but I'm not sure that all these details will absolutely be necessary throughout the course. Probably a good familiarity with a lot of this stuff is good. But as far as using things like the Vertex and translations and things like that, that's more of, this is going to be more of a review to kind of just familiarize you with this stuff. So that if it does come up, you'll kind of already be familiar with it. So we'll start with basic definition. So the definition of a quadratic function, we have f of x equals ax squared plus bx plus c. A, b, and c are all real numbers. A is not equal to 0 because if a is equal to 0, that term would go away. We would just have bx plus c, which is linear. So b and c can both be 0, but a cannot be 0. Now we have a couple of graphs here, and we'll spend just a minute talking about these. So the basic quadratic function is y equals x squared. It looks like this. Comes through the origin, turned up. So both directions are going up as we move off to infinity. Now this one over here, x squared minus 4, looks like this one, but we are shifted down. So this minus 4 is shifting the x squared graph down. And we're going to talk about shifts in the next video. That's the second half of this section. So we'll see a lot more of that and what happens if it's plus 4, what happens if we put a negative in front of the x squared and all that kind of stuff. Now, this one, let's talk a little about the characteristics of the quadratic. And I put a list of things in Canvas on the page for this section. We'll kind of mention these here. I didn't explicitly put those in the lecture notes, but you can find those on Canvas. Now, so this one, y equals 3x squared plus 2x minus 1. It's hard to tell a little, this one, the minus 4 obviously shifts it down. This one, the minus 1 still shifts it down, but it's a little bit harder, I guess, to tell, what is the 2x doing? What is the 3? What is the 3 doing here? So we'll just point out some things. So this point here is negative 1/3, comma negative 4/3. That is the vertex of the parabola. So the vertex is wherever it changes direction. So we're coming down this way. You get to the vertex and then you start going up, or vice versa. You can obviously have a quadratic that opens down like that. So then the vertex would be there. We're going up and then we hit the vertex and we go down. The other thing to note is this does open up, like I said, or some parabolas open down like that. The other thing to notice is we are symmetric around the vertex. So you can imagine a line going like that through the vertex, and we are symmetric around that line. So that line is called the axis of symmetry. All right, and then we'll talk about, as we get to an example here in a minute, how to find the axis of symmetry, how to find the vertex, and in general, how to graph this. So let's look at this first example, and I have the graph. Actually, I don't have the graph for that one. I thought I did. Maybe it's another one. So let's just talk about this. There are many things, many ways to graph this, or many things, I guess, that we need to get while we're getting the graph for this. So the first thing we need to do is find the vertex. Find the vertex. So how do we find the vertex? So we have ax squared plus bx plus c. So in this case, a is negative 4. B is negative 8, and then C is 5. So to find the vertex, we are going to use the formula. So the vertex is an ordered pair. The x-coordinate of the vertex is negative b over 2a. All right, so b is negative 8. So that means negative b would be positive 8. over 2 times a, which is negative 4. So we get 8 over negative 8. So the vertex, the x part of the vertex is negative 1. Now the way to get the y part of the vertex is just plug this x part into the function. So we're going to find f of negative 1. So negative 4 times negative 1 squared minus 8 times negative 1 plus 5. So we have negative 4, negative 1 squared is 1. So negative 4 times 1. So negative 4 plus 8 plus 5. So that'd be 4 plus 5, which is 9. So the vertex is negative 1, comma 9. We could also find the y-intercept. Y-intercept is pretty easy to find. If you remember from one of the last videos, I think it is section 1.2 maybe, to find the intercepts, we plug in 0 for the other variable. So in this case, find f of 0. So f of 0, plug in 0 for x, and f of 0 is just going to be 5. So the y-intercept is 0, comma 5. And then the last thing that you need is to find the x-intercepts. And you probably remember this from algebra or pre-calculus. There could be 2 x-intercepts, there could be 1 x-intercept, or there could be no x-intercepts. So the way we're going to do this is we're going to just set this equal to 0. 4x squared minus 8x plus 5. And possibly, let's divide out a negative. I prefer to have that first term be positive. And let's see, we're just going to trial and error this. We're definitely going to have a negative 5 and a plus 1 to make that negative 5. And then let's try 2x and 2x. And actually we need to do a plus and a minus there. All right, so we have 2x plus 5 and 2x minus 1, and that will work. All right, so let's set that equal to 0. So 0 is 2x plus 5, and so we'll get negative 5 halves for that. And 2x minus 1 equals 0, so x is 1 half. So our 2 x-intercepts are negative 5 halves and 1 half. All right, so let's plot all these points. And when you plot all the points, you will get your parabola. So here's our vertex, negative 1. I won't count up 9 of these. We'll just kind of estimate. I believe on my math lab, all of these, if you have to graph any of them, all of them it's multiple choice to pick the right graph. So as long as you can draw this semi-accurately, then you're going to be good. The y-intercept, so we need to get this point on there, this point, and then negative 5 halves, 0, and 1 half, 0. So if you plot all of these points, then you can get the shape of the graph. So the y-intercept would be about there. So there's 9, so we need to go 0, 5. And then negative 5 halves, so there's negative 1. We'll call that 9. We'll call that 5. And so negative 2, and we'll just say negative 5 halves is there. So there's negative 2. There's our x-intercept, and then 1 half. So if we put 1 there, there is the other one. And so you can see, I'm just going to come down and like that. And really, you don't even need the y-intercept. You can, and obviously this should be kind of more rounded, but we're just drawing by hand. So something like that. If you find the y-intercept, the x-intercepts, and the vertex, you can plot those points, and you're good to go. Now, it's possible you don't have any x-intercept. So for instance, if this one had this vertex and open up, it's never going to cross the x-axis. But you can still plot the vertex and the y-intercept and then kind of just approximate. We're not having to be perfect sketch artists here. But those are the 3 steps that we need. If you want the axis of symmetry, The axis of symmetry is just x equals the x-coordinate of the vertex. So in this case, x equals -1, and that would be a vertical line coming right down through there. All right, next. Oh, I did have that. Yeah, so there it is. Just move to the next page. Yeah, so that's what we got. All right, and then next one, we have y equals x squared plus 4x plus 6, and we're going to graph this one just the same way. So let's find the vertex. I don't know why it keeps doing that. Get rid of that. So find the vertex. I won't write out steps, but we'll follow the same steps. So a equals 1, b equals 4, c equals 6. So we have x equals, now I do recommend, you don't need to write out find the vertex if you don't want to, but I do recommend any formulas that you use, write out the formula before you plug things in, unless you're just extremely confident that you can remember it without ever writing it down. Some formulas are like that, I'm sure, but if you have any doubt, go ahead and write it out before you fill it in, and that'll help you remember it. So x is -2. Now plug in -2 for x. So we get 4 minus 8 plus 6. So I think that would be 2. And so our vertex is -2, 2. All right, find the y-intercept. So y is going to 0 and 0, plug in 0 for x, and so the y-intercept is 0, 6. So we have that point, and now let's find the x-intercepts. I don't think that factors. So 3 and 2 are the only ones, or 6 and 1, but we're not going to get either of those to add up to 4. So let's use the quadratic formula. Quadratic formula, -b plus or minus square root b squared minus 4ac over 2a. So -4 plus or minus square root 4 squared minus 4 times 1 times 6. And we're going to get complex numbers here. So that is negative. So we'll just go ahead and write -4 plus or minus square root. That's 16 minus 24, so that's -8. So we're not going to get any real zeros. And we'll probably see when we get over here, 1, 2, so there's -2, and there's our vertex. The y-intercept is 6, so we'll call that there. And like I said on the last one, this is going to not cross the x-axis. So no x-intercepts, and we can see that from here. Okay, so and that way you can be sure, and you could actually save yourself some time if you plot these as you go. If you plot your vertex and then your y-intercept is up here, there's no way to get back down here. So you already know just from those 2 points that you're not going to have an x-intercept. So you could kind of do this either way. For instance, on this last one, if you plot the first 2. If you plot the -1, 9, and then the 5, you know it's going down like this. So you know it's going to cross. So then you can go ahead and work that out. Or you could do this one, and then you plot these 2, and then you know that you don't need to work out step 3 to find the x-intercept. But either way, just again, this goes back to confidence. The more you practice this, the more confident you get with what you need to do and what you can kind of get away with not doing maybe. So again, just all goes back to practice. All right. So if you have any questions, you can let me know, and we'll finish up this section on the next video.